everyone, I'm Bridget.
And I'm Sophia.
And today we're going to talk about the biological significance of iodine.
Iodine was discovered in 1811 and has the atomic number of 53 with an atomic weight of approximately 127 grams per mole. It's a halogen and it's in column 17 of the periodic table. Iodine is relatively large with an atomic radius of 198 picometers. Remember that a picometer is 10 to the negative 12 meters. So though it's relatively small, in comparison to its congeners, it's quite large. Iodine is a faint metallic lustrous solid at room temperature, but it has the ability to sublime to a violet gas.
The thyroid gland is a butterfly-shaped gland located around the neck where thyroid hormone is produced, which regulates metabolism. When your body is cold, your brain will sense this and cause the thyroid gland to release thyroid hormone, which will increase metabolism, warming up your body. Thyroid hormone is made in the follicles of the thyroid gland that look like a bushel of grapes. The precursor of thyroid hormone is thyroglobulin that contains the amino acids tyrosine that will be iodinated. The iodinated tyrosines will come together to form T3 and T4 that eventually become thyroid hormone, which is released into the blood. This is extremely complicated, but just know how important iodine is to make thyroid hormone. Now we'll look at different disease states. First, hyperthyroidism is caused by an excess of thyroid hormone. Symptoms include increased heart rate, blood pressure, body temperature, and a hyperactive state. Graves' disease is an example in which the eyes will bulge, and that's called exophthalmos. The opposite is hypothyroidism, caused by a thyroid hormone deficiency. An example is cretinism. Low thyroid hormone levels cause a decrease in mental development in children. Finally, goiter is hypothyroidism caused by dietary iodine deficiency. This will cause an overstimulation of the thyroid gland, which will cause the bulging to occur.
But have no fear. Food to the rescue. Iodine is an important trace element in the human diet. A trace element can be defined as a chemical element needed in minute amounts for proper growth and reproduction. By minute amounts, we mean small, like less than 100 parts per million small. Plants and animal sea life absorb iodine in water. Seaweed has an undoubtedly high concentration of naturally occurring iodine. As mentioned above, goiter is caused by a lack of iodine in the diet, and a healthy dose of the trace element is necessary for proper functioning of the body. A study performed assessing the consumption of iodine by Japanese individuals shows that Japan is the only non-goiterous country in the world, with approximately 1 goiter for every 1 million Japanese people. In the United States, seaweed consumption is not as popular as in the East, and certain measures have been taken to ensure that people do get the recommended dose of iodine in their diet. In 1924, Morton salt created iodized salt in order to eradicate goiter. Interestingly, as people in the United States have begun to eat more processed food that contains less iodized salt, the daily intake of iodine has decreased. So now some information about radioactive isotopes of iodine. Iodine-131 and 123 are isotopes of naturally occurring iodine. An isotope is an element that has a differing neutron count from its naturally occurring state. Just as a reminder, subatomic particles are those that compose the nucleus and the electron cloud surrounding an atom. It's like comparing elephants and rhinos to ants, where the size of an elephant and a rhino is the size of a neutron and a proton, whereas the size of an ant is the size of an electron. So, an isotope is the addition of an elephant, and it changes the mass of an element in question. Iodine-123 will lose 4 of its elephants, and iodine-131 will gain 4 of its elephants, commonly known as neutrons. Alright, back to chemistry. Iodine-123 is a radioactive isotope, meaning that it becomes more stable by alpha decay, in which it gives off an alpha particle. An alpha particle is basically a set of 2 protons and 2 neutrons, and it's produced in this reaction. Aside from this particle, antimony, with an atomic symbol Sb, is also produced. So, iodine loses 2 neutrons and 2 protons in the form of this alpha particle. Iodine-123 is a usual isotope used for imaging and understanding the activity of an intact thyroid gland, since it's harmless to the thyroid cells.
Next is I-131, which is going to be used for eradicating cancers. I-131 will undergo beta-minus decay, which will produce a beta-minus particle and xenon. We can liken this process to a water balloon. As more and more water is added to the water balloon, it will eventually explode. So as more radioactive I-131 is added to the thyroid, you'll eventually explode the thyroid and all the cancerous cells. This is an effective treatment for stubborn cancer cells. So what do we take with us today? Iodine is a trace element that's vital for proper functioning of the thyroid gland. Dietary imbalances of iodine are dangerous, and radioactive forms are useful for imaging and eliminating thyroid tumors.
So eat more seaweed.